So your homework for tonight, 2/27/2013, is an introduction to Chapter 7, Lesson 6. If you could please take out a sheet of paper and write your complete heading at the top. For the title or the assignment name, you can write Chapter 7, Lesson 6. Example number 1. The plans for a set of stairs are shown below. Using points X and Z, find the slope of the line down the stairs, and then verify that the slope is the same at different location by choosing a different set of points. So if I start at point Z, I'm going uphill. I am counting up 2, 3, 4, and I'm counting over 1, 2, 3, 4, 5, 6 to get to X. And that's what they asked me to do, using points X and Z. And if you recall, why was I counting the rise over the run? Because the slope is represented by the letter M, and we always count it as the rise over the run. And so my slope for X to Z or Z to X is a positive slope, 4 over 6, and I can reduce that to 2 over 3. Now, if I shrunk that distance down and I counted from Z to Y, I'm counting, if I change colors here, maybe see it a little bit better, counting up 2 and over 1, 2, 3. Well, counting up 2 and over 3 is the same as it was at a different set of points. So I have specifically answered by verifying different location of a different set of points. Skip a line and put example number 2. It says triangle ABC with vertices A, -6, -1, which would be right here, B, -4, -1, and C, -6, -3. That makes triangle ABC. You would normally use a straight edge, and I don't have the capability to use a straight edge on this program. So there's my triangle ABC. Triangle NLM has vertices -3, +3, 0, 3, and -3, 0. So if I connect those points together, I get a similar triangle. And now I have a line going up like so, where I can calculate the slope. So if I count rise over run, I'm really just following the point here, counting up 2 and over 2. And if I counted from this point here all the way up to this point here, it should still reduce to the same thing, which is 1 over 1. So I count up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6. So at any of the locations, the slope of this line is always going to reduce to 1 over 1. Example number 3. Triangle FGH is at 2, +3, G is at 2, -1, and H is at -6, +3. So I have this triangle, and JKL, which is 0, 2, 0, 0, and -4, +2, which is this triangle kind of inscribed inside the bigger triangle. And so I'm focusing on the slope of this line here. And it's a negatively sloped line because it's going downhill from left to right. And so I'm going to count downhill. I'm going to count from this point here to this point here. I'm going to count down 1, 2, 3, and over 6. So down 3 over 6, which reduces to -1 over 2. And I can do that for many other points also. I can count this from this point here. I'm going up, but backwards. So I'm counting up 1, 2, 3, 4, and back 8. So I have of that I am going up 4 but back 8, and 4 over negative 8 reduces to a negative 1/2, which, again, the same slopes. And the last example that we're going to do for tonight, example number 4, it says a ladder is leaning up against the side of a house. Use 2 points to find the slope of the ladder. So you can use any 2 points here. I'm going to use U and T. And then verify that the slope is the same at a different location by choosing a different set of points. So from U to T, I'm going to count rise 1, 2, 3, 4, and over 1, 2. So I have a slope of rise 4 over 2, which reduces to 2 over 1. If I change colors and I go from maybe S to V, I'm going to count rise 1, 2, 3, 4, 5, 6, and over 1, 2, 3. And so that blue slope was 6 over 3, which again still reduces to 2 over 1, slope being a constant rate of change.